Hello everyone, hope you all are doing well. So today we are going to do topic 7 of paper 2, that is polyploidy. So what is polyploidy? It is the heritable condition of possessing more than two complete sets of possessing more than two complete sets of chromosome. I am writing chromosome here in shorts. You should elaborate in your notes. So it is the heritable condition of possessing more than two complete sets of chromosomes. See, you can see here. And some estimates suggest that around 30 to 80% of all living plant species are polyploids. More than 30, around 30 to 80% of all living plant species are polyploids. Now what is the application of polyploids? Application. They are helpful in mutation breeding, in seedless fruits, bride crossing, ornamental and forage breeding, disease resistance through aneuploidy, We'll discuss aneuploidy in the coming lectures. So first you will see polyploidy here. So it is helpful in disease resistance. It has many industrial applications, enlargement of increased vigor, creation of sterile triploids, Next we can see overcoming barriers in hybridization, enhancing stress resistance. It's helpful in both disease resistance and stress resistance. So these were the applications of polyploidy. Now moving on. What are the disadvantages of polyploidy? Disadvantages of polyploidy. Here we can see changes in cellular architecture and regulatory implications. Changes in cellular architecture and regulatory implications. We often see difficulties in mitosis. We also see here difficulties in meiosis, and because of these two difficulties, it leads to aneuploid gametes. Rates of ploid gametes. We will discuss in detail what aneuploids are, euploids are in the coming lectures. Regulatory changes in gene expression. Regulatory changes in gene expression, epigenetic instability. Inbreeding. So these are some of the disadvantages of polyploidy. Now moving on, what are the applications of allopolyploid? Applications of allopolyploids. This is a type of polyploid. So it acts as a bridging species. In transfer of characters. From one species to another. It helps in production of new crops. Example, you would have heard about Raphanobrassica. It helps in widening. Genetic base of existing allopolyploid crop species. Widening genetic base of existing allopolyploid species. Interspecific gene transfer. That is from one species to another. Tracing the origin of crop species helps in tracing origin of crop species. So these are the applications of allopolyploidy. Now we will move on to the next topic, that is usage of autopolyploidy in crop improvement. Usage of autopolyploidy in crop improvement. Triploid watermelons are produced by crossing. Triploid watermelons are produced by crossing tetraploid, that is 4x tetraploid female and diploid male, that is 2x male lines. And triploid sugar beets produce large roots and more sugar. Large roots and more sugar per unit than diploid. More sugar than diploid sugar beets. Autotetraploid cabbage. And turnip are larger in size and water content than diploids are larger in size and more water content than diploids. In ornamental tetraploids, the flowers are larger and longer flowering duration than two diploids. In ornamental tetraploids, the flowers are larger and longer, they show longer flowering duration than diploids. The only autotetraploid commercial variety are of rye. Only. Let me make some space. This is fifth point. Only autotetraploid commercial variety are of rye. Example, that is double steel of tetrapecus. Double steel of tetrapecus. So these were the uses of autopolyploidy. Hope you all understand this. So that's all for today's session. For any queries, do comment. If you like it, please press the like button. Do share and subscribe. Keep making your notes. Keep value adding to the notes. That's all for today. Have a nice day. Thank you.